Yeah, so we are talking about the redox reaction over here, oxidation reduction reaction, and I just started with oxidation. So what I was saying, oxidation reaction is nothing but addition of oxygen to some substance or removal of hydrogen from the substance. That will be called as oxidation reaction. So if that is oxidation, then what is reduction? It will be just the opposite of oxidation. In oxidation, what was happening? Oxygen was getting added, no? So remove it and it will become reduction. So removal of oxygen. And what was happening to hydrogen in oxidation? It was hydrogen was getting removed. Here hydrogen is getting added. So just the ulta of oxidation. Removal of oxygen or addition of hydrogen. So I want everyone to read this definition on your own and tell me if you understand this. All of you read this on your own.
Sir, it's not necessary that both should have happened.
No, no. Any one thing is happening, then you will call it as that reaction. It's not both. It's not like both of them has to happen. No. Any one thing is happening. Either oxygen is getting added or hydrogen is getting removed. You will call it as oxidation. Either oxygen is getting removed or hydrogen is getting added. You will call it as reduction.
So the same way both is not happening, sir. Like in some cases,
It will always happen together. I'll show you in the example. Oxidation and reduction, they always happen together. So everyone has read through the definition once, right? At least, okay. So here I've just written the note that oxidation and reduction always happen together, which I have explained to you. And we will understand why that happens through the example. And this is just a note that will tell you that redox reaction means the same thing. Oxidation and reduction is also called redox reaction. Now let's get to the example, which will actually explain things to us. Okay. So let's look at this example. What is happening? We have hydrogen, and this is your, what compound is this? Can anyone name it?
Copper and oxygen.
Yes, but they are not separate. This is copper CuO. So you will call it as copper oxide. Okay, this is a compound, single compound. This hydrogen is separate. It is reacting with copper oxide. So when that is happening, you see what happened here. The oxygen from here went to hydrogen. So oxygen got added. Where did it get added? To the hydrogen. So hydrogen is the one which is getting oxidized. So addition of oxygen is happening. From H2, it became H2O. So here oxidation happened. But like I told you, in every reaction, if oxidation is happening, reduction also has to happen. Why? Because see, oxygen was already there and it got removed from here and it became only Cu now. And what did I tell you just now? Removal of oxygen is also called reduction reaction, right? So reduction is also happening over here. So if oxygen is getting added to somewhere, of course, it has to come from somewhere, no? Wherever it has to come from, like CuO over here, in this case, copper oxide. Oxygen has come from this place. So this is the guy who oxidizes hydrogen, and hydrogen gets oxidized to become H2O. Tell me if that makes sense.
Sir?
Yes, tell me.
So for CuO, we call it as copper oxide. So what do we call H2O?
H2O. We call it water, but this is hydrogen. This is also an oxide of hydrogen. Okay, water is also an oxide of hydrogen.
Sir, from the classical definition, for oxidation, removal of hydrogen is also there. So
So like I told you, not both of things have to happen at the same time. Any one is happening, you will call it as oxidation. So since oxygen is getting added over here, hydrogen is not being removed from anywhere over here. Hydrogen gas was there and oxygen just came and attached to it. So that's why we are not saying that hydrogen is removed over here. But oxygen got added, so that is enough. That is enough to tell you that oxidation has happened. Okay. We will take examples of hydrogen getting removed also, and we will call it as oxidation reaction. Okay, don't worry. Up to here it is clear so far?
Yes, sir.
All right. Okay, so before I move ahead, let me explain you a few things about whenever redox reaction we are studying about, there are a few things which you need to know. Okay, you need to know that who got oxidized and who got reduced, or which compound got oxidized. Which compound got oxidized? It's an important question. They'll give you some reaction and they'll ask you to tell who, which compound got oxidized, which compound got reduced. And then there are two more things. If something is getting reduced or oxidized, the other guy from the reactant actually becomes the reducing agent or oxidizing agent. So
Sir,
yeah,
sir, in this one, the one who got oxidized will be hydrogen
yes,
and the other one will be copper.
yes. The one which got reduced is copper oxide, not the copper. After being reduction, it became copper. But who got reduced? It's the copper oxide that got reduced. Reduced to
Yes,
what?
sir.
Reduced to copper. So the compound which got reduced is copper oxide. These two questions clear to everyone?
Yes, sir.
Now you need to understand a little bit about the oxidizing agent and reducing agent. They are in the same reaction. And like you see, both of these answers for these questions, who got oxidized, who got reduced, they are both in the reactant. You never have to answer something from the product. Okay, your answer will be in the reactant for these questions, the four questions which I'm talking about right now, which I'll explain. So two questions are here. First one, what got oxidized? Hydrogen got oxidized. What got reduced? Copper oxide got reduced. Okay, so if something is getting oxidized, the other person, like hydrogen, if hydrogen is getting oxidized, why did it get oxidized? Because copper oxide was there and it facilitated this oxidation. So because of that, CuO becomes the oxidizing agent. You know, right? They will facilitate something. That's how this copper oxide becomes the oxidizing agent. And since copper oxide got reduced, why did it get reduced? Because hydrogen was there. That's the guy. That's the culprit. So H2 is your reducing agent. Tell me if everyone understands what I have written here. If hydrogen is getting oxidized, copper oxide becomes the oxidizing agent. If copper oxide is getting reduced, this hydrogen becomes the reducing agent. Guys, are you with me?
Yes, sir.
Yes, sir.
Okay. What is the time now?
6:30, sir.
Oh. Okay, we have time till 7 o'clock, right? What is our timing? I forgot totally.
7 o'clock, sir.
7, sir.
Okay, yeah. Fine, then. That's okay. All right. So everyone is okay with this example?
Yes, sir.
Okay. And these two are the other question. Who got oxidized? Who got reduced? And what is the oxidizing agent? And what is the reducing agent? That's your 4 questions. So let me write it as this: oxidizing agent becomes copper oxide, and the reducing agent becomes your hydrogen. Now let's get to the next example. Okay, so this is your reaction. Now tell me, where is the oxidation happening? Where is the reduction happening? Who can tell me?
Sir, oxidation with hydrogen sulfide, sir.
Yes, hydrogen sulfide is getting oxidized to become sulfur. Why are we calling it oxidation? Even though there is no oxygen, but there is a hydrogen here which got removed. So we know that removal of hydrogen is also called oxidation. Removal of hydrogen, and that's why this is oxidation is happening here. And what about the other one? Where is the reduction happening? See, this chlorine, hydrogen got added, right? So addition of hydrogen, what did we call it? Addition of hydrogen is called reduction, right? So when chlorine became HCl, hydrogen got this hydrogen, you see, it got added to chlorine. So addition of hydrogen, that's why it will be reduction. Tell me, is it clear so far? Where the oxidation is happening, where the reduction is happening. Now you have to answer the questions like, what is the substance that got oxidized? What substance got oxidized?
Hydrogen sulfide.
Okay, hydrogen sulfide, is that correct? Everyone agrees?
Yes, sir.
So this got oxidized. And what got reduced?
Chlorine.
Chlorine, sir.
Cl2. Yes, chlorine. So if that is the case, then what is the oxidizing agent here?
Chlorine, sir.
Chlorine, sir.
Yes, it has to be chlorine. Chlorine becomes the oxidizing agent because H2S got oxidized because of chlorine. So chlorine is the one which facilitated the oxidation. That's why oxidizing agent is chlorine. And of course, the last one, reducing agent. What will that be?
Hydrogen sulfide.
Hydrogen sulfide.
Yes. So everyone is clear with these two examples. You see, in the first one, it happened because of oxidation, addition of oxygen or removal of oxygen. That gave rise to the redox reaction. Oxidation happening between from H2 to H2O and reduction from copper oxide to copper. In the second reaction, there was no oxygen, only hydrogen was there. And we know that removal of hydrogen causes oxidation. So H2S got oxidized to sulfur and chlorine got reduced to hydrochloric acid, HCl, by addition of hydrogen. And these four questions, of course, everyone understands this. Okay, more examples. So after the class, I will try to organize these examples a little better and I'll send you the notes. Okay, so let's say I have zinc oxide reacting with carbon to give you zinc plus CO. What is CO, guys? Anyone knows what is this compound?
Carbon oxide, sir.
Yes, it's an oxide of carbon, but it has a specific name. Have you heard it?
Carbon monoxide, sir.
Yes, it's carbon monoxide. Why? Because carbon makes two kinds of oxides. When carbon combines with only one oxygen, you get CO, which is called carbon monoxide. And when carbon combines with two atoms of oxygen, CO2, everyone knows this as carbon dioxide. Monoxide, dioxide. Everyone knows that?
Sir, CO3.
CO3 is not a stable compound on its own. So that becomes carbonate basically, but that's not a compound. It's like it bonds with some other things. Okay. So when you have to write the oxides of carbon, you will just write these two oxides of carbon, not CO3. Okay. Like I told you, CaCO3 is there, but this is CO3 is not a separate compound. Okay, this is an ion which is bonding with calcium to form calcium carbonate. Okay.
Yes, sir.
Okay. Carbon monoxide, very nice, guys. Very nice thing, right? We should have this around us. Anyone knows about carbon monoxide?
Sir, it's a harmful gas.
Not just harmful, it's very, very poisonous. Even a small amount of carbon monoxide is totally lethal. It's dangerous for human life. Okay.
Sir, it will burn the lungs.
Takes away all the oxygen from the blood. So anyway,
Yes.
yeah, we were talking about the redox reaction. So let's not deviate from that. Yeah, look at this reaction and tell me where is the oxidation happening and where is the reduction happening.
Carbon is oxidized.
Okay, substance oxidized. Kavya says it's carbon. Is that true? Everyone agrees? Is it carbon? So the substance which get oxidized, see here it was carbon and then it became carbon oxide. So oxygen got added to carbon, no?
Yes, sir.
So this is where your oxidation is happening. Carbon getting converted to carbon oxide, carbon monoxide, which is addition of oxygen. And that's why this is oxidation. Now, where is the reduction happening? Of course, the remaining two. But why is it happening?
Oxygen is removed from zinc.
Yes, here it was oxygen was there. Here it's no oxygen, means oxygen got removed. So removal of oxygen is also called reduction. Okay, now answer me these questions. Yeah. Substance oxidized?
Carbon, sir.
Yes. That's good. Substance reduced?
Zinc oxide.
Yes. Kavya, your answer was right. So I was just checking everyone, whether everyone really understood this, okay? Fine. So what are the oxidizing agent? What is the oxidizing agent over here?
ZNO, sir.
Yes. The compound which got reduced, that becomes your oxidizing agent, which is zinc oxide. And the reducing agent will be, of course,
Carbon.
tell me, everyone is okay with this example also?
Yes, sir.
Yes, sir.
Who's missing? One person is missing.
Nitya is missing.
Nithya has still not joined. Okay, maybe some connection problem. Okay. One more example. So I'll write that over here. Okay. Tell me, guys. Same thing. What's happening here?
Hydrochloric acid is oxidized, sir.
Oxidized to what? Say that again. Couldn't hear you. Anyone? What is getting oxidized? What is getting reduced?
Hydrochloric acid is oxidized. And
So this is
then
oxidized to what?
water.
Okay. Oxidized to water. Okay, is that correct? Everyone agrees? What is happening? What is the reason for this oxidation?
Oxygen is added to.
But here I'm seeing that oxygen is added to hydrogen, not hydrogen chloride. So how can I say that hydrogen chloride got oxidized to H2O? Can we say that?
No, sir.
No, sir.
So that's not correct. Think more. Think a little harder. Remember all the definitions of oxidation and reduction.
Hydrogen chloride is reduced, sir.
Okay. So hydrogen chloride is reduced to what?
To chlorine, sir.
What is the reason?
Hydrogen is removed.
The removal of hydrogen. Okay, I agree. It was hydrogen chloride here. Hydrogen got removed. Only chlorine atoms are remaining. So it's chlorine. Okay. But removal of hydrogen, what is it called?
Oxidation, sir.
Yes, it's not reduction, it's oxidation. Okay. Removal of hydrogen is oxidation. I know this can be a little confusing in the beginning, so don't worry. Try to get this, get your head around this thing. What is getting removed? What is getting added? Can be a little bit testing. Okay. So it's okay. So HCl to chlorine, and I said that what's happening? Hydrogen is getting removed, and that's why it is called so this is oxidation. Is it clear to everyone?
Yes, sir.
Yes, sir.
Okay. Now tell me what else is happening here. If this is oxidation, where is the reduction happening?
To MnO2.
Yes, MnO2 manganese oxide is getting reduced to manganese chloride. Here oxygen got removed. There is no oxygen over there now. And then chlorine also got added later. That's okay. We don't care about that. But here, at least this we know that here it was manganese oxide and the oxide has been removed over here. Okay. So removal of oxygen. That is the reason over here. Removal of oxygen, we call it as reduction. So very quickly answer the 4 questions. Yeah, tell me very quickly.
A substance oxidized will be 4HCl.
Okay.
This one will be chloride. Or will it be chlorine?
No. All answer to all these questions is always there in the reactant. You never have to go to the product.
Yes, sir.
So
Sir,
HCl, yes, it's manganese oxide, MnO2. So substance which got reduced is MnO2. That's what we have put the arrow from here to here. It is getting reduced to this compound. Okay. things also. I forgot to put the arrow over here. Here and what's this one? Like this. Yeah. This one, tell me this answer. Very, very fast. You should know this by heart now.
Hydrochloric acid.
Oxidizing agent will be the one which got reduced. Which got what got reduced here?
MnO2, sir.
Yes. MnO2 is the oxidizing agent. The one which got reduced, that becomes your oxidizing agent. And the one which got oxidized becomes the reducing agent. So it will be HCl. Okay. Okay, so very quickly, let me write down the definition of oxidizing agent and reducing agent, and then I'll give you more examples of this. I will write down more examples and I will send this to you later, okay? Yeah, I will write down a few more examples and then I will send it to you. But you can note it down in your notebook as soon as possible and try to remember as many reactions as possible. Try to remember everything. You may have to put a little bit of hard work. I know that it's not easy, but if you go through that hard work a little bit now itself, during the exam time and even in your board exams, all other exams, whatever you write later, it will become very easy if you put a little bit of hard work now. So make sure do that, okay? And if it feels difficult, something is not, if you're not able to remember some reaction, if it feels very difficult, talk to me about that, okay? Let me know. We'll talk. We'll see. Or I will write these definitions. Yeah, everyone has understood, no? What is an oxidizing agent? The compound which got reduced, that becomes your oxidizing agent. And what is the reducing agent? The compound which got oxidized, that becomes the reducing agent. So I'll write those definitions and I'll give some examples and then I'll send it to you people. So that'll be all. I'll send you the notes within some time.
Sir,
Yes, tell me.
so sun is made up of which element?
Sun.
Yes,
Okay.
sir.
See, all the stars, whatever we see, everything, there is a fusion reaction going on in all the stars. The reaction is called fusion reaction. Okay, and in this reaction, what is happening? Hydrogen is getting converted to helium, heavier atom. Normally, what you see in normal conditions, what happens? Something which is heavier breaks down into smaller things, right? But you know, this is a star. The pressure, the temperature, those things are very, very high, higher than anywhere else on the earth. Nothing can be that high as what is happening on the sun or any other star for that matter, right? So that is why what is happening? Hydrogen, which had only one electron, they are combining together. The atom itself getting fused and they're getting created. New atoms are being created over there in the stars. Hydrogen is getting converted to helium. And in the
So is this how helium element came to be in periodic table?
yes, exactly. This is how not only helium, but every other element what you see in the universe, everything has come from the stars or some, not only some star like sun. If the star is much bigger, when they explode, when supernova explosion happens, if you know about those things, That is where all these compounds have been created in stars. Each and every cell in our body are created with atoms, right? So every atom what we have in our body also today, it was created in some star somewhere, probably sun or maybe some other star, we don't know. Everything is
Are we descendants of stars?
absolutely, yes, 100%. Everything, whatever you see around you, human or non-living, non-living, whatever you see around you, everything is made up of atoms, and those atoms are created in some star somewhere. There is no other manufacturing unit. Only manufacturing unit in the universe is the stars. That is where all the atoms get created.
Sir, the core of the sun is solid?
Core of the sun, yes. If I remember correctly, it is solid right now also. And ultimately, when all the hydrogen, whatever you, I'm telling you that hydrogen is a fuel, right? When all this hydrogen on the star gets used up, when there is no more hydrogen to convert to helium, then what will happen? Then another reaction, another chain of reaction starts. And that is when the end of any star's life starts. The star dies at that time when all the hydrogen gets over. And when that happens, a star like sun will become a red giant star. It'll become swell. It'll swell very. It'll become bigger, and it'll become red in color. And at that stage, you call it as a red giant star.
So it has already started, right?
No. We are in the midway of sun's life. Sun is very young right now. It's in the mid of its life right now. So how much, since it was born, how much ever time has passed, that much more time is there for the sun. So don't worry, sun is not going anywhere right now. Okay.
Sir, so whatever the elements made by man, like, are they also present in the stars?
See, humans have never been able to make any elements. We have just changed their state structure, modified a little bit, added something else, combined together. But we have never created an atom. As far as I know, they are trying to create, of course. Maybe they would have tried to do something in the latest. If you read some latest paper, they would have done something. But so far, human beings have not been able to create anything. It's not easy to create atoms, okay? Because if that was possible, then what we will do?
So by joining two elements, we are making a new element, right?
See, when you join hydrogen and chlorine, you are not creating a new atom, no? You took the hydrogen which was already there, you took the chlorine which was already there, you just bonded them together and they are sitting together now. Earlier they were alone and now they bonded together, they're together, you made a new compound. Okay, so there's a difference between creating an atom and creating a new compound. Compounds can be created. You can take more different atoms and try to mix them and see if they react or not. So those different compounds, of course, a lot of chemists try to create new compounds. That is possible. Okay. Yeah. So the story about star, that is very interesting. When all the hydrogen gets used up, helium starts it becomes a red giant star, and when that explodes after some time, there'll be only the solid core of the sun left, and the gravity of that will be so huge that it will try to implode. It will try to go inwards. It will try to crush itself. It will become smaller and smaller. Okay.
Sir, it will also attract the neighbors of itself.
Yes.
And then they will also join in this center.
Yes. Depending on the size of the star, different things happen to different size stars. Okay. So a size of the star which our sun is, that will become a white dwarf at the end of its life. It's called a white dwarf. It will cool down. It will have a very solid core. The gravity of a white dwarf is also huge. It's very strong gravity. And helium would have got converted into heavier metals like even bigger compounds. After that, hydrogen is just atomic number 1. This is 2. So it will get converted to heavier atoms.
So is there any star known which has become solid and blasted off?
Yes, there are like billions of stars which got the, yes, scientists they have studied about so many stars like that. It keeps happening every now and then. It's a very common thing to happen for a life of a star to get over. You know, right? There are
Like,
like
I mean, famous one. Famous, like, it's,
see,
that one is very, very famous. Everyone almost knows about it.
is it? I don't remember the name of any such famous star. But of course, there can be something which would have happened. I'm not sure about any names of as of now. Okay. Yeah, but exploding of a star is a very common phenomenon. Somewhere in some galaxy keeps happening every now and then. Okay. That is how scientists came to know about all these things. No? They saw what's happening. You know, Hubble telescope is there in the space, right? It tries to take pictures from different galaxies far, far away.
So, which is your favorite galaxy?
Of course, the galaxy which we are living in. If this was not there, where would we be? This is the galaxy which has created a home for us, no Earth, because there is no other place on this universe so far. People have tried to look everywhere. They couldn't find any life anywhere. They couldn't find a planet where life could be possible. They are looking at a few of them. Some planets far, far away. They are seeing that they are at a position where life may be possible, but still there is no certainty. So imagine we have seen the whole such big part of the universe and the small speck on that Earth. That's the only place where we can live in. We can't survive anywhere else. That's how important our Earth is. And that's how important our Milky Way is also. Okay, so I think we have spoken enough.